So thanks so much, Mel and Catherine, for organising this, and nice to meet everyone virtually. So my name is Rob Catchlove, worked in water for 20-something years, and I'm presenting today on behalf of Wave Maintenance, which is our sister company to Wave Consulting. And I think it's really important for me to acknowledge that a lot of the hard work gets done by a couple of other people in the business. In particular, I think you guys might know Ralph Flyderer and Derek Maguire. So we're going to take you through a bit of an interesting journey we've been doing with maintenance. But first, I'd like to acknowledge the traditional owners as well. I just use this photo because this was a photo I took when we went to a really interesting session in Torquay near Geelong in Victoria. The Warrawong put on the 26th of January, a dawn session. So it was really, really interesting. And today I'm on Wurundjeri land, but yes, of course, pay my respects to elders past and present. So here's a nice pretty picture of Ralph and myself out doing some auditing of some wetlands that was on that particular day. Water system design maintenance didn't stop in COVID, just got a little bit harder, must say. But I guess what we'll try and do is talk a little bit around our experience in being on the ground and maintaining these assets, and hopefully giving you some hope at the end of all this, that this is actually a good news story. I'm going to focus particularly on a lot of the really urban assets here, the rain gardens and street trees. I just wanted to acknowledge that as a business, we kind of work across all sorts of other things, rainwater tanks, green walls, larger fire retention systems. We've done some maintenance of permeable paving, stormwater harvesting assets, and so on. But we're going to really focus on that sort of urban environment, the small spaces. It was really interesting to put together this slide and sort of really think through, why are we talking about this? Why is there still such a significant need to ensure that these assets are built properly and maintained properly over the whole life of the asset? And as I was sort of putting all this together, I realized it is a still feel where we've got Everest to climb in terms of trying to get water system design adopted in cities. It's mostly not maintained well. It's rarely built well. It's not prioritised. There's so many other kind of competing factors for a council and developers to consider. I think it's a really important one. The benefits are not monetised. What price is a healthy gulf or bay or ocean and rivers? So much goes on, I think, particularly around maintenance, around the myths and the negative perceptions. It's still the dominant story, I believe, in the broader sort of drainage planning sort of city space. Most people still rarely have budgets for them. They're actually incorporated into open space budgets predominantly, occasionally into drainage or pit maintenance. But, and this is the critical thing, that despite all of that, it really, I believe, is a critical part of what sustainable cities and taking action on climate change is all about. Climate adaptation, resilient cities, air and water quality, livability, urban ecology. These sort of things can be really maximised through good water system design and the adoption at so many different scales. I'm going to try and flick through this as quickly as I can because I think I've got about 20 odd minutes. As I said, we're going to focus particularly on the highly urban sort of areas. I've got all sorts of bad pictures, so I just wanted to start with the better picture straight away. This is I think it's about a 700 square metre rain garden in Fitzroy North. Vast majority of these photos are from Melbourne, this one is integrated into a parkland, very highly active, used, lots of different spaces. But the integration has sort of worked really well. We had an interesting experience coming back. This was about 10 years old. Had an interesting experience coming back to this to replant because some of the issues were the operation of this was starting to struggle a bit. I do like this spreading of the water. So I guess one of the critical things we'll talk about from our experience with maintenance is you must allow the water to flow through the entire asset. And that is predominantly what we see is not working that well. This is another fairly good example. We've got about a sort of 1.2 metre wide rain garden. We've now introduced some more trees. We've got some spreading. We've got other urban, sort of infrastructure right next to it. You can see some slots of the rain sort of getting in. It's about 500 metres from my house. It's an easy one to take a photo of. There are actually some street trees further down. I've got an example of talking about the maintenance of these. So they can look good. They can work well. This also does need maintenance, and we've done a few, one-off maintenance exercises of this as well. Here's Ralph in action, and again, sort of highlighting the point that when we're maintaining these assets, there's a lot going on in the streetscape. So part of our challenge is actually ensuring that this little bit of the streetscape is functioning and doing what it needs to do well, but it sort of integrates well into the rest of the landscape. So that means parking is an issue. Other parts of the road reserve. So, obviously the council's relying on the mowing of this from local residents, and they're not necessarily doing it that often. Another thing I wanted to highlight was the way that this overflow within the rain garden is flush with the surface. That is not the way we're trying to design these assets, and then has particular issues in terms of the runoff. So we start dumping sediment, other litter, rocks, other things like that into the drainage system. It's becoming a source of pollution as opposed to what it's meant to be doing, which is preventing pollution. I use this one as a little example, as well as trying to highlight that as environmental assets that we're trying to incorporate into the urban landscape, less concrete is better. Less rock, less concrete. These are a couple of things that we'll be going on about through here. And the option to sort of incorporate overflows in particular and inlets into existing curbs just reduces the amount of concrete that we can use as we're building them. Concrete is a very emissions intense material. So I think there's an onus on us to ensure that we can design these in a way that limits the use of that type of material as well. So here we get into some of the typical assets that we've been maintaining, and this is a lot of these sort of photos of the way the assets were when we first started. So our experience is maintaining these, sort of car park, rain garden, tree pit kind of assets in a council called Stonington in a city council of Melbourne. And we've been doing that for about 5 years now. And when we first got them, most of them have been in for about 15 years. So 10 years into their life, and most of them were looking quite a lot like this. Particularly poor health, very bad aesthetically, didn't seem to have had that much maintenance, despite various in-house and external contracts that have been in place. So one of the key things that we find when we're maintaining these assets is, first of all, that water runs downhill. If we put this little inlet section of the rain garden here, it is actually higher than the curb. So it's not doing its job very well. And it's not allowing the water to then, deposit. So we had a few high flow events that probably came as much off the footpath as they did the street. So we're trying to design all this stormwater off the road to flow through this system, but water flows downhill, and it's incredible to see the number of assets we go out and maintain or audit and find that that's probably not going to be happening. A critical thing that we're finding with so many assets is that we do need a good 100 mil set down from where this last curve is to the rain garden, because things will accumulate. They're designed to accumulate there. And as soon as if it's less than 100 mils, very quickly the inlet area is doing what it's meant to do, which is start to deposit some of the sediments. And then it actually forms a barrier, and then we won't get any water going into the asset at all. Just a lack of maintenance through this one. Vegetation density, is essentially gone. So we've been out to sort of try to look at replanting that. Worst case scenario, a lot of people wonder about the overall life cycle and how long these things are meant to last. We generally can tell you that if you can scrape off 250 mils, you can and relay that topsoil, then essentially you can start again with a new asset. So the replacement cost is not the same as the original capital cost. That's a really important point. And rock. So we've got a few more slides looking at this, but it's very common for people to put in these little, rock inlets to dissipate flow as it comes in. So that's important. We don't want the whole system scouring out, but what it does, it means all the debris in the sediment accumulates around here. And our experience is really the only way to get it all out is with your hands. And so you're literally, you know, sort of sitting down or on your knees with gloves, trying to scrape all that sort of material out. So think about the frequency of how often you'd like to do that personally. If you're, you know, designing, building, you know, have any involved in these sort of assets, it's not fun. Rock on. This asset was an interesting one. It's completely undersized. It was an opportunistic exercise. Let's chuck a rain garden in at the bottom of the street, fairly high gradient, and they just filled it with a whole lot of rock. And so again, on the basis that will again dissipate flow, but and then trap some of that sediment. And then there's another little grate system to try to capture some litter as well. Again, to maintain this, it's really, really hard to do. And so if you want to talk about the cost of maintenance, you need to think about how many hours you will sit on the side of this footpath and clean out the sediment. So if you don't do that, it will eventually block and bypass. So then we've built an asset that's not going to work. And, you know, there is a lot of pollution coming off our streets. So there's a frequency element to this as well. This is the sort of classic example. We're now working with the council around what sort of options there are to rectify this. But this catchment ratio just gets loaded so much with this level of sediment and litter coming off the catchment. And inlets a very, very tricky one. And I guess Ralph sort of, I think, describes this quite nicely when he's out doing training and so on, which is like, you know, what we want with inlets into rain gardens or street trees or the rest of it is we want the water. We don't necessarily want all the pollution, but it comes with it. And so there's a lot of interesting examples where people are essentially trying to say, you know what, we'll just try to do this at a particular angle or a particular opening, and that just lets the water in, and then we'll let the street sweepers or someone else clean out that inlet. All the councils, I think that are online at the moment, will tell you street sweepers don't come past anyway, but these are just going to clog very quickly. This photo on the left doesn't show you that this is on quite a gradient as well. So our theory is that the water is basically just bypassing. And I always sort of say to people, it's really, really important that we get the right amount of water into these assets and we inundate the entire rain garden or street tree, and we get the most value in terms of water in the landscape, biodiversity, tree growth, all these sort of different things. Because otherwise, I say it's like building a library and putting 20% of the books in. I mean, why would we do that? You know, we really want to get the most out of these assets. I'll move on to looking at a few street trees. So I don't need to tell everyone here, but street trees are just so valuable in the urban landscape. This isn't even a passively watered street tree. This is actually in Western Sydney, and you're just showing you that the land surface is 30 degrees cooler under the shade of those trees. We've got all sorts of other examples of that. When we've been maintaining these assets in Stonington, and when we were first there, a couple of really, really interesting things happen. First of all, what you choose to do with the grate around the tree has a very big influence on how easy it is to maintain. This is cast iron. So, I mean, I reckon I've gone close a number of times to, you know, dislocating or breaking my fingers trying to lift this up to access the surface of the street tree to ensure that we're managing that sediment. Its sediment load is just such a critical influence over the whole system. Without sort of some sort of regular maintenance, then this sort of stuff will happen as well. All the weeds start establishing, growing in there. And as I said, bypassing. So we're not getting water into the tree like we wanted. But the choice of the grate is just so interesting and so varied. This is another one, same council, and it's got these little inlets on the side. And then there's another photo I've got, like, as in it's about 40 or 50 mils to get that out. You can access this particular street tree from the grate above. That's actually easily removed. That was well thought out, so we can access it there. But we still need to clear this to ensure that the water will flow in. That becomes very, very tricky to do. And this is a really built up area. A different grate system again. It appeared like these were bolted down. This happens quite a lot. People like to have all sorts of attachments around the grate itself, around the tree, which is annoying because we then need to carry with us all sorts of different, drill bits to get them off. This one actually wasn't attached to anything though, so it appeared like it was bolted down, but it wasn't. But this one's at least a lot easier to lift up and inspect. I think this is the same one, and just sort of showing you that over time it will build up in terms of the sediment and the organic load. So it's just an issue around the sort of the frequency of how often we need to do that, with an awareness that this is a real balancing act, I think, for the arborists and the urban forest people, in terms of trying to set the tree down a little bit so we have some sort of extended tension and area where the sediment and litter can accumulate, and then clean that out. But they don't want the tree sort of too deep. And then the tree roots, I guess, obviously being quite present in the top sort of 300 mils. So this was just an example of how quickly things kind of accumulate. I don't think you can quite see it on here, but as soon as there's a building site, there's a little bit of concrete that starts washing in, and that really obviously is kind of quite detrimental to what the tree's designed to do. It's not designed to take that kind of chemical pollution. Reliance on street sweeping again won't sort of really happen. This is still a mystery to us. Yes, we get there's some cigarette butts and the rest of it, and this is sort of like a typical amount of litter and sediment that you pull out of a street tree like this, just one tree. So that is the level of pollution that's kind of constantly flowing through our cities and going into drains and rivers. But the mystery for us is still, and it's very present on this particular set of assets, there's about 90 of these street trees in one place, is human hair is clogging up the inlets. It's human hair, it's not dog hair. We kind of want to know it's a lot of dog walkers around, and that's what's going on. It's human hair, and it's not like, and it's across all the inlets. So it's not like it's just only outside the hairdressers. It's a really strange phenomenon that we're still not quite sure, but it does clog it quite quickly. Some more street trees. This was the little unit that we now carry around with us to try to scrape that through. So what we need to do is push this through to this area to be able to access it. So the access to this surface particularly around the inlet, is so sort of critical, and it's just trying to easily manage that amount of sediment. These are actually a couple of rain gardens. This is sort of find this little photo here quite interesting, because the rain garden itself is only about sort of 4 or 5 square meters. The whole sort of reserve around it maybe 20, 30, 40 square meters. So the perception of this asset is a function of mostly what's all around it, not so much the actual rain garden itself. And, again, with sort of this idea about just chuck a whole lot of rock around, and that sort of creates a sort of a cleaner aesthetic, I think. And then people have been using it in rain gardens. That is very problematic for us in terms of maintaining it. So we don't want rock mulch. We don't really want rock around it. If we had the thermal imagery again, looking at this, you're just baking up the surface. It's just so hot, but it's particularly hard to kind of then extract. So what we're doing is we're pulling in new materials like rock mulch, then some 5 years later, needing to take it all out again and dispose of it. So it's a bit of a defeatist approach. Last little thing on tree grates. This was just down the road from that place. I said it was 500 meters from my place, the rain garden. These are very kind of nice in the angles and the rest of it. This is permeable paving. So this is like not a bad idea to kind of get some permeability over the surface of that. Seamlessly kind of integrates with the footpath there and the rest of it. Here's our inlet, needs a bit of a clean as well. But the point about this one was that block there, that permeable paving is around about 50 mil thick. It's a really, really hard ask to actually lift it up, and that's the lighter one. Obviously, that's slightly bigger. And then once you've lifted it up, you really want 2 people there, because if you get it vertical and then it starts to sway a little bit, it's going to someone's walking past. It's quite dangerous. This one looks a little bit easier to lift up, and then we realize that the actual tree guard is attached on top of it. So it's virtually impossible without getting out an angle grinder to access the underneath of this tree now. So it's just a design, sort of issue that that I think two different teams would have been involved in. One working out how we do the water sensor design underneath and the type of tree, and then designers coming along and talking about how they'll protect the tree. But they just weren't talking to each other, and now we just can't. You can't slip this off because the branches have gone through it. So we're really advocating for these little more open inlets and easily accessible lifting grates around all the trees. There are, definitely good examples of this. This is sort of a similar type of issue with the tree guard, but you'll notice that it sits through the middle of the system and then either side can be lifted. So there are design solutions for this, but it's just quite interesting in terms of how often these issues are playing out. And going to people that are trying to budget for how do we maintain this, this is what we need to think about. How long does it take to actually access what you're needing to do? How many extra materials will you need to bring with you? So it's quite a different proposition to actually worrying about let's just charge this as a function of cubic meters of sediment litter you're trying to pull out. Ideally, yes, but in reality, no. Like we're actually a lot more thinking around the time and our access to the site itself. Water does flow downhill, so if we can allow this inlet to, have a little bit more space in here and a drop down, then this water that's ponded, we're out there while it was raining, so we could see this happening, and we're auditing this particular site, would then obviously flow in. Several studies have confirmed this, but when we talk about litter, over 90% is organic. There's the odd inorganic, the bottle and so on. And as a business, we focus quite a lot on being able to extract the leaves and ensure that they get put through green waste. So we don't want to send all this sort of stuff to landfill. The other kind of key point that we see a lot of is a lack of extended detention. So as I kind of showed in one of the early ones, rocks will just keep getting washed in, kicked in, driven in with cars. Obviously, someone's taking a shortcut over their driveway here. But having all our outlets flush with the rain garden permeable base really ensures that, and we did a little bit of modelling, which I'm about to show in a sec, to sort of work out what the difference is in terms of the effect of filtering and the amount of water that you kind of keep in the landscape. And stop all this rock then flowing into the pit, the overflow pit there. So we can fix it, and we just wanted to sort of highlight one of the really simple things that we've started to do with some of these systems, which is it's $79 at Bunnings. There's a little stormwater pit here, 450 by 450, that we've now starting to put in, and council agreed that we should go back and retrofit so many of these and put that in, and that keeps all that sediment there and stops it flowing through the rest of the system. It means we can just lift off a grate with one shovel, clean it out, and then we're done. This is one of my favourite sites because A, the neighbour was quite invested, but B, it's just got a really good level of coverage. It's got really good kind of exposure. It's got the tree. Now it's got this sort of inlet sediment capture. We're really confident that one's going to keep going really well. And this is what it then looks like. So this is the crux of us being able to demonstrate that we can improve the performance of the assets and save time and therefore money and cost for councils as the main client to do this. So this is what it then means. We can take the grate off. We can easily lift that out. We're not seeing anywhere near, like there's orders of magnitude less sediment so starting to flow through the rest of the system. $79 at Bunnings, that's literally what we did. We then had to set it in and so on. And then they're starting to really look good. We did this because this was actually falling in. We had to reset that. So we're, we have to deal with some of the, the pits, the drains, the curbs, as well as all the vegetation and the surface itself. But we're really, really confident that these are doing what they're meant to do, starting to look better, functioning, and we're able to do it more efficiently. Data, I guess, underpins a lot of this sort of stuff, and so it's, I think we're going to hear a bit more about data collection process and the rest of it. We've had this in place for a good 5 years of that contract, and then some other contracts that we've had. We can upload photos and those sort of things, but it's very, very useful. It's anyone that on our team can do it. We're all contributing to the central database. I guess we wanted to just sort of show that as we then use all this data and report back to council, we collect more sediment than litter. So if you kind of imagine that it's pruning and it's litter is the kind of key thing, actually in terms of, kilograms and, what we load onto the back of our truck, there's more sediment than anything else. We often get asked to sort of verify how things are actually working, and then we get into infiltration testing, sort of flagging that we've sort of done that on a number of different places. I was trying to work it out yesterday. I think we must have done over 250 of them by now at all sorts of different council areas, all sorts of different assets. And usually it all comes back to this same sort of issue in terms of how much does the sediment affect the whole system, ratio of catchment to treatment area, how well it's being maintained, and these levels and extended detention. A few more quick slides and then I'm done. So we had a go at trying to think about, well, what does this actually all mean in terms of the impact? Once we get it working well, we're managing that sediment really well, and we've had to increase planting density and so on. What sort of happens? These are where all these assets are. We're talking about over 200 of these assets, street trees and rain gardens, pretty urbanized and continuing to become even more urbanized environment. Chapel Street, one of the famous, sort of shopping strips in Melbourne, series of rain gardens along there as well, they're all included. And what we've found is that if we think about how much pollution in the form of, TSS and TN and so on, we think once we get them working, we are reducing the amount of pollution that's going downstream. So we're getting a lot less. These things are doing what they're meant to do, essentially. The crux of this is that the key variable that we change to work out what the impact is that moment where it gets too blocked and it starts bypassing, then the asset is not doing anything. So we kind of went into the specifics of looking at it with the frequency of that and so on as we maintain it. But this I found a really interesting one when we kind of then looked at particularly getting the inlets right, and those little sediment traps. And then the use of the extended detention. So we've actually been back and retrofitted some sites to ensure that they actually retain more water. And you get a 600% increase in the amount of water that's kept there. If they've got any trees around them, then obviously that helps a lot in terms of tree growth and shading, going back to that whole urban heat issue. And so then we've been through a couple of different tendering rounds for this particular council. And so what was really, really interesting is that once we deliberately invested quite heavily in early on in the project. And so while we might have allowed 1 hour to go to some of the assets, we were finding we were there for, sort of 2 or more hours because we were finding that they were in such sort of poor state and really needed to be kind of cleaned out. That now that we've got a lot more confidence in the way they're working, when we went to retender, whole lot of new assets were found magically and added to the contract. But we worked out with the frequency and the time it takes us to get the work done, we could submit a new price that whether it's by number of assets or by square meter, it's almost similar. It's around about a third cheaper in terms of per unit. That's how much confidence we have. We can keep these things in the performance and the state and the aesthetic. We can do that by visiting them, potentially less frequently because of these sediment traps and so on that are in place. And we're just getting more and more efficient. Obviously, we run a pretty lean business. We don't have big offices and the rest of it. It's just mostly the truck and off we go. So we try and keep it pretty lean. But this is the evidence. This is what actually happened when we went back to retender that. We're able to give them essentially a similar price, but maintain more assets. So I think this is the really good news story. We get it right, and you're proactive about it. Hence the name of this whole session. Then it's really possible to get more for less. Sound like I'm selling something at Coles. So a couple of quick things to finish on. Just have to manage the sediment. We need to not have sediment trashing these systems and underestimate the impact of that. Planting density, if you can really look closely at what the planting density is and the diversity of species, that's trying to move away from monocultures through these systems. We've got to stop putting rock mulch in. We've got to think very carefully, I reckon, around how much concrete we use when we're building these assets. we must have some extended attention. That is the water and the landscape element that really delivers and improves, and of course improves the pollution retention and so on. And yeah, water flows downhill. Keep thinking about what will happen with these subtle changes. And we used to think that the key problem in the industry was that that no one had a budget for maintenance. What we've since found is that people do have budgets for maintenance. They're just incorporated and used in all sorts of different ways. We had an interesting experience where we were looking at trying to forecast the 10-year budget program, and we used the kind of rates in terms of the way we would quote it, and found that the council's in-house team was actually budgeting something far bigger already, but maintaining less assets. So it's sort of like, I think it's our experience, we're able to go, no, we have a lot of confidence we can do this for a smaller budget. So it's not that there's a lack of budget all the time, but they're incorporated into open space budgets, all sorts of different things. It's just trying to get clear about exactly what that is, which assets are on the list and how they're being maintained.
Thanks so much for that. I'm sure Bunnings are going to sell out of those little pits pretty soon. So I've just got some questions in the chat for you. The first one was a question about organic hardwood mulch in rain gardens and impacts on maintenance. What are you finding? Places that have used that?
Nothing comes to mind, so I'm drawing a blank on that one. I'm trying to think where we've seen that.
So that's good. So people aren't using it. So people aren't using it. So it's not blocking up their drainage system.
No, not seeing very much of it. And I guess we generally just try to say, look, it's planting density. You can let's try to move away from all the different various mulch solutions. We get planting density right, we should be okay.
And Andrew King had put that in the chat, so that's good. Very consistent message that we're giving, so that's excellent. Then we just had, so just to clarify the question from Andrew, the pit that you've installed at the inlets is basically a pit that's not connected to any drainage. It's virtually just a sediment trap, correct?
It's a sediment trap. It's just a standalone sump. So we don't pull it out ever. We just leave it in situ, and then we use a shovel to, which the 450 is important because you think about how wide the shovel is. Then we can get a good shovel in there, 1 or 2 scoops. You've got most of it, and then you're off again, and you put the grate back on top. So it's not connected to the other drainage. There's no bypassing. There's the rest of it. Of course, it will fill up if you don't go back and have a look at it again. But in terms of the frequency, we've found that it's been about right, that kind of size. Normally rain gardens are sized to heat, up to 100 something square meters of runoff, give or take. But yeah, it seems to be working well. But absolutely right, there's no other connections into other parts of the drainage system.
So what I was hearing from your talk is that you had a big, almost like a rectification maintenance right at the start. Then did you really find that you're just doing minor maintenance, or do you have this kind of regularity of a minor maintenance routine and then more of a major maintenance routine?
No, we had it exactly right, Mel. So what we had was we got the original contract. We did that for 12 months. As I said, we invest a lot heavily in terms of the time and the materials we were taking out. We then said to the council, look, if we want to get these onto a better trajectory, can you find some rectification budget at the end of the financial year? And then luckily enough, they said yes to that. And then we're now back into, since then, it's just been regular maintenance ever since. And I said, we went through a contract renewal process, and that's when we kind of had a close look at all the figures and you really get to know the spaces really well. And we're like, yeah, this is looking a lot better than it used to be. We could definitely, and it's pretty subtle, in terms of putting into the specification, go there every month, and we can say, we could go there every 6 weeks, not every 4 weeks. And that's enough to start saving you a significant amount of money. And then that same budget can be spread over other assets as they come online.
Excellent. All right. Well, look, thanks so much. We might get you to just pause there because I'm sure we might, if we've got time, then we'll have some more questions directed for you, I'm sure.